Okay, so we have one more example in 6.3. It's on page 91. And it's really a fabulous segue into 6.4, into hypothesis testing. So I just want to make sure I do that before you start the videos in 6.4. So you can see here we have a new technique called balloon angioplasty. It claims to open clogged heart valves and vessels. The balloon is inserted via catheter and is inflated, opening the vessel, thus no surgery is required. So here's where we're learning about something new that has nothing to do with statistics, right? The surgical technique for unclogging valves and vessels has a 60% success rate. Ooh, we just found something. Nothing is in this sentence to tell me that this success rate is an estimate or that it's from a sample. So we're going to go ahead and call this P, right? 0.6. And I'm going to make a note, because it matters in this one, that this is for the surgery. Then we see a preliminary clinical trial is conducted to test the balloon technique. So now we're talking about something different, because they told us that, remember, the balloon is non-surgical. So 50 people with clogged vessels are given the balloons and 39 respond to those techniques. So when we're talking about the balloon, looks like they've given us, same as we saw in all of our beautiful confidence interval questions, an N and an X. So the number of people we looked at and then the number of successes. First question here says calculate a 90% confidence interval for P, the true proportion. And there needs to be a little bit more here. It should say the true proportion of people who respond to the balloon technique. I'm just making a point to say this because if we're talking about the surgical technique, apparently they gave us 0.6, and even if 0.6 is an estimate and not the true proportion, we don't have the necessary information. So, but we can do this for the balloon. So we're trying to make a confidence interval. If you don't have the big calculator, you're going straight to your formula sheet. And you're going, okay, formula sheet tells me I want to do a confidence interval. We're talking about proportions. So I'm doing this. And I'm just going to write that formula down on my question. So I'm going to do P hat plus or minus Z star square root P hat Q hat divided by N. The square root got really big. All right. And then we can plug and chug, right? First thing we need is our P hat. So those of you with the calculator, you can just zoom ahead to the end if you know how to do the calculator stuff. But those of us without, P hat is equal to X over N. 39 divided by 50. My stylus is really dying, guys. Just got to get through one more video. 39 through 50, over 50, which is 0.78. So here's my P hat, 0.78. If your P hat has 4 decimals, you better keep all 4 decimals. Plus or minus, we'll go grab our Z star. This is again on page 201. I have not done anything good about making sure I have that so that I don't have to, don't know if I have my formula sheet somewhere. Sorry, I'm looking now. Formula sheet. No, I don't need, I need the T-table. T-table, yes. Yeah, open it. Living on the edge here, opening too many documents. Aha, this doesn't look exactly the same as yours, but this is the same idea. We have our Z stars. That is not my highlighter. I have my Z stars here, and we want 90%, so we're just going to grab that 1.645. So 1.64, oops, that's not what I meant to do. 1.645. I'm going to throw that in. And then we're back to other stuff. Square root, we know P hat is 0.78. Q hat is 0.22 then, just 1 minus. And this is all over my N of 50. And we learned in class that it makes a lot more sense to go ahead and just calculate the margin of error all at once. So get really good at typing this into your calculator. So 1.645. Oh my God, times my square root of 0.78 times 0.22 divided by 50. No need to use any of the parentheses that are there. The parentheses are just multiplication, right? So we do all of that, and now we have our margin of error. We have 0.78 plus or minus 0.0964. And we can subtract that and add that to get back to our value. So 0.6836, 0.6836 to I don't remember. I thought I'd keep it in my brain. 8764. I also can't do the simple math in my head. Okay, so interpreting your interval. I want you guys to take a stab at that on your own. Take a second, pause the video, see if you can do that. If you're doing the calculator shortcut for confidence intervals, just remember the first one I would have just done stat over to tests, past the 1 prop z test, past the 1 prop z test, all the way down to 1 prop z interval, and then you just type in all the things you have. 39 was our x, 50 was our n, and make sure you enter your confidence interval or confidence level as a decimal, so 0.9. And it gives us the exact same confidence interval that we got using the formula. So the interpretation, we can be 90% confident that the true population proportion of patients, people, whatever it might be, who respond, and honestly, we could be even more specific here. Obviously, these are people with clogged vessels who respond to the technique. Is between 0.68 and 0.88. I would write all the decimals, I just ran out of room, and I'm telling you, it's real hard to use the stylus right now. Okay, so the part that helps us lead into this idea of hypothesis testing is this last question. Do you think there is evidence for the superiority of the balloon technique over the surgery? Explain. So here's what I want you to think about this for a second. Remember, we know the surgery is 60% successful, and we now have this statement that we just made. Hopefully you'd say, yeah, there is evidence. Because look, we're 90% confident that it's between 68 and 88, which is higher than 60%. So no matter what my P is, if it actually falls in my confidence interval, like I hope it does, because that's the point of my confidence interval, it's got to be better than 0.6, right? So this is what we're getting to, is that there are two things we can do in statistics. One is that we can estimate and try to say what we think possible values are. The other is we can test actual hypotheses or statements to see if they're true or not using our statistics and probabilities. So that's where you're moving in the next couple of videos that I'll be checking in class on Tuesday.